All right, so we're going to take a look at the looking back problem number 1. Thank you. So we have a contest where the first question you get right, you get $5. And then for every additional correct answer, you will get $10 more. So I want to make a table of this so I can understand what is actually happening here. So if I have my question number, how about N for number of questions, and D for dollars. Oh, it says N and P. So I won't do D for dollars, I'll do P for prize. So I always want to start my tables at 0. And I'm just going to make this short little table so I can figure out what type of relationship we're dealing with here. So it says $5 for the first question. I'm going to get $10 more for getting the second question right. So that's 5 plus 10, that's 15. 10 more for the third question, so that's 25. $10 more for the fourth question, that's 35. And so I'm taking a look at this relationship right here, and I'm going up by, I'm adding 10 every time. That is the hallmark of a linear relationship. And I know a linear relationship is going to be written in the form y equals mx plus b, where m is the slope. In this case, the slope is clearly 10, so y is equal to 10x plus b. So my b value is going to be my y-intercept. So I have to work backwards so that some number plus 10 is 5. Well, to do that, I'm going to subtract 10 from 5, and I'll get negative 5. All right, so that means my y-intercept is negative 5. So I have y equals 10x minus 5. All right, so I've got that equation. Great. Oh, that's question A1. So it's question A2. How many questions would a contestant need to answer correctly to get at least $50? Well, so I'm going to use my equation here. 1 second, please. Sorry about that. So I'm going to put 50 into my equation and then solve for how many questions. So let's go with, so 50 is my prize, right? So that's my p value, and x is going to be my number of questions, of course. So p is going to be 50. So 50 is equal to 10n minus 5. So add 5, and I will get 45 is equal to 10x, divide by 10, divide by 10, and I will get 4.5 is equal to, in this case, n. So that means at my fifth question, when I get my fifth question correct, I will have $50. And then for $75, instead of writing 50 here, I'm going to write 75, which I should get an exact answer, right? So it's going to be 8, isn't it? 8 questions. And then for 100, I would plug in 100 for P. All right, so that's how we go about doing that. For question number 2, Armando thinks, hey, this is a great idea, but you know what? We should probably give people more money. He's a very generous soul. And so he says, you know, instead of adding $10 every time, let's double it. So for n questions, and we have our p, let's figure this out. Again, we're going to start with 0, 1, 2, 3. So at 1 question, it's $5. At 2 questions, we're going to double that. That's 10. At 3 questions, we're going to double 10. That's 20. At 4 questions, we'll double that. We'll get 40. Oh. So at first, we would have to pay out less money, but in the end, we'd have to pay out more money if people kept getting it right. So what type of relationship is happening here? Well, this looks like it is not adding.
She's there.
Okay. We are multiplying. We're multiplying by 2. Multiplying by 2. Multiplying by 2. That is the hallmark of a exponential growth relationship. And so to get the y-intercept, I have to work backwards. So something times 2 is 5. Well, that something clearly is 2.5. 2.5 times 2 is 5. And so my equation is going to be P is equal to, well, an equation of an exponential relationship is going to be written in the form y is equal to a times b to the x power. So my y-intercept is 2.5 times 2 to the power of n. All right, and then I could do the same thing. Now, clearly, it's going to. I haven't taught you how to solve if I put a number right here. So in that case, we are left with continuing our table. So here's 80. Double that, that's 160. And now I'm able to answer these questions right here pretty quickly and easily. For question 3, who wants to be rich? It almost sounds like Who Wants to Be a Millionaire. And whenever I think of Who Wants to Be a Millionaire, it always ends with a great movie. How many of you have seen Slumdog Millionaire? No? It is rated R, but it is a great movie. It was made this century, though. Decade. I don't know if this decade, but okay. So the purchaser will keep half the ticket and add the other half to the ticket to the entrance to the drawing. All right, so we have a ticket that is 60 by 60, which has an area of 3,600. And we keep ripping it in half. So every time we rip it in half, the area decreases by a factor of 2, or 50%. So we know that this is exponential decay. And exponential decay, again, will be written the same way exponential growth is. So what is my y-intercept? It's 3,600. I'm ripping it in half, so that means my decay factor is 1/2. Incidentally, a decay factor of 1/2 is the only one that will have the same decay rate. It will be a decay rate of 50%. And so my area is going to be equal to 3,600 times 2 to the x power. All right, that's fun. Moving on to the next problem. True or false? All right, so I'm looking at this rule, and this rule is reminding me of the rule that says if I have the same exponents, so if I have a to the x times b to the x, I will multiply the bases and keep the exponent the same. So 3 times 6 is not 9. 3 times 6 is 18, which would make this false, according to this rule. My next question, well, this one is a little tougher, but I can't help but notice that 8 is a factor of 2, isn't it? Yeah. Okay, so 8 can be written as 2 to the 3rd power, and we're taking it to the 5th power. And we're going to multiply that by, well, 4 is also a power of 2, right? So 4 is just 2 squared. And we're taking that to the 6th power. All right. Well, this reminds me of the rule that says a to the x to the y power is equal to a to the xy power, so you multiply them. So let's go ahead and multiply these. 5 times 2 is, 3 times 5 is 15, so we have 2 to the 15th. And we're going to multiply that by, well, 2 times 6 is 12, so this is 2 to the 12th. And now this is making me recall the rule, a to the x times a to the y is equal to a to the x plus y. So I add the exponents. 15 plus 12 is 27. That is a true statement. So for problem number 6, we have 2 to the 0. Now anything to the 0 power is equal to 1. So I'm not going to worry about 2 to the 0 at all. 6 to the 7th, so we have 6 to the 7th. over 3 to the 7th. All right, now this is a little bit tricky, right? Now notice how we have the exponents that are the same, but the bases are different. Well, that's kind of like problem number 4, but in 4 we had multiplication, right? So in problem 4, we multiplied the bases and kept the exponents the same, which must mean the opposite of multiplication is division. So really, I should be able to divide the two bases and keep the exponent the same. So 6 divided by 3 is 2, and we keep the exponent the same of the 7. That is a true statement, folks. All right, problem number 7, fractional exponents. Well, the 2 in the denominator means we're taking 8 and we're finding the square root of 8. Yikes. What is the square root of 8? I don't know either. All right, so that is probably kind of a dead end. So I think I'm going to have to probably do what I did in problem number 5 with the 8. So I'm going to say that 8 is equal to 2 to the 3rd, and I'm going to take that to the 3/2 power times 2 to the 1/2 power. Now I'm just going to use this rule right here, multiply the exponents. So 2 to the 3rd times, or to the 3/2 power, well that's going to be 2 to the 9/2 power, because I'm just multiplying the numerators, right? Then I'm still multiplying it times 2 to the 1/2 power. Okay, so here now I'm adding the exponents. 9/2 plus 1/2, hey, welcome, is equal to 10/2. So 2 to the 10/2 power, well, that's just equal to 2 to the 5th. 2 to the 5th is 32. So this is a true statement. Oh, this reminds me of our warm-up. So we have 1.39, and we have to, oh, that's a -5. Already I know I'm going in the wrong direction, so that's clearly false. They just went in the wrong direction. For this one, move the decimal place 6 spaces. 1, 2, 3, 4, 5, 6. Yep, that's what they have here. That is a true statement. All right. Hey, boys and girls, do you have any questions on this problem? All right.